Before we continue with the isomeric inductive effect, let us practice a few questions from Hyperconjugation.
मैंने डॉट से कभी क्लास से मैंने कंफ्यूज हो गई थी इसमें जो कल हमने इंडक्टिव इफेक्ट पढ़ा था तो उसमें आपने बोला था कि लाइक हमने कार्बन और फ्लोरीन का एग्जांपल लिया था कि फ्लोरीन इज मोर इलेक्ट्रोनेगेटिव देन कार्बन। तो अगर उसके अकॉर्डिंग देखें I प्लस के अकॉर्डिंग तो दैट मींस जो कार्बन से जो इलेक्ट्रॉन ले रहा है
Carbon to electrons provide. Plus I group means electron donating group. Electron donating group means electron releasing group. That means they are releasing their electrons to the carbon chain. So carbon के respect में तो it is the gain of electron, but with respect to group it is the donation of the electron.
तो अगर जैसे फ्लोरीन कार्बन से एक इलेक्ट्रॉन लेता है तो वहाँ पर कार्बन को पॉजिटिव चार्ज देता है.
Now carbon is having positive charge, that means it is short of electron, that means it is electron deficient, so it will, अब वो क्या करेगा? So it will try to take up the electron from the next carbon bond.
Because तो फिर नेगेटिव चार्ज नहीं आना चाहिए अगर उसके अकॉर्डिंग देखें तो.
क्यों है? जब इलेक्ट्रॉन्स देते जा रहे हैं वो, देखो, that is what I said, that in inductive effect, that's the polarization of electrons. It is not the ionization क्या positive negative की बात कर रहे हैं. It is simply the distortion of the electron cloud. उसका मतलब ये नहीं कि completely वो उसके पास चला गया, वो उसके पास चला गया. No. It's the polarization. तभी तो मैंने लिखा है कि inductive effect में while applying that you need to check the sigma bonded molecule. Sigma bonded molecule and one more thing, electronegativity. The tendency of an atom to attract the shared pair of electrons in a covalently bonded molecule. ऐसे तो NAF भी होता है, NaCl भी होता है, but in that case we won't be talking about polarization. That's the concept of ionization. ठीक?
और उसमें कल आपने ये लिखवाया था कि फ्लोरीन ऑक्सीजन NH3 आपने सीरीज लिखवाई थी. तो इसमें हमें जैसे पता चलेगा कि जैसे कार्बन दे रखा है तो ये Sp होगा या Sp3 होगा कैसे?
Carbon in the form of triple bond. That's Sp. This is acetylene. So if I ask you what is the hybridization of this carbon? Sp. Why? Because देखो sigma and this bond is also sigma. I told you while predicting the hybridization you don't need to count the pi electrons. So there are two sigma, that means it is sp hybridized, as simple as that. Because the pi bonds are formed by the unhybridized p-orbital.
Yes.
But sp hybridization means one s and one p of carbon, they are intermixing together in order to obtain a set of orbitals which are degenerate. That means they are having the same energy. And these two pi bonds, they are formed by the unhybridized p orbitals. So if I ask you what is the hybridization, that's sp. You will not, because these pi bonds are not formed by the hybrid orbitals. So why would I count them in hybridization? They are formed by pure p orbitals, which are unhybridized. Okay. And same goes with, if I ask you in ethene molecule, what is the hybridization of this carbon? So you will say one sigma. Basically, there are two hydrogens.
Yes, sir.
Sigma, sigma, and sigma, and this is pi. So 3 sigma, that means sp2, sp2 hybridized carbon. And this pi bond is formed by the unhybridized or pure p orbital. So we won't be counting that in hybridization. Chale. So before I continue with the inductive effect, let us practice a few of the questions. Write I-effect nomenclature. I'll be giving 5 to 6 molecules or compounds daily for writing the I-effect nomenclature. Now, before I start with the I-effect nomenclature, we would be discussing the benzenoid bonds today. So can you please tell me the name of this? Yes, tell me. Toluene. Toluene. Can you please tell me the name of this? aniline is again. And one more. What is the name of this?
Anisole.
Anisole. Anisole. That is ethoxybenzene. Okay. Having said that, let us start writing some of the names. Alright. Very quickly, write the name of this. And please consider the lowest locate rule.
Two chloro, four nitro, anisole.
2-chloro, 4-nitro, anisole. Alright.
Anisole.
Anisole. Alright. So, the naming from here 1, 2, 3, 4, 5, and 6. Look here. This naming is absolutely correct. Why? Because the chlorine and anode were the substituents, right? So, if you start from here, it's 1, 2, 3, 4. That means 1, 2, and 4 is the locate set, or 2 and 4 is the locate set. If you start from here, 1, 2, 3, वो तो गलत हो गया, ठीक है? And so yes, it's absolutely fine. This is 2-chloro, 4-nitro, anisole. Absolutely correct. Absolutely correct. Next. All right. Tell me.
Sir, 3-methyl 4-nitroadenine.
Very good. 3-methyl.
Then 4 nitro.
Okay.
Yes, absolutely correct. 3-methyl. 4-nitro. And absolutely. Okay, with this, one more. What is the name of this? What is this?
Phenol.
Phenol.
Sulfate.
Phenol. Phenol. Very quickly.
Sir, 3-4-dimethyl phenol.
3,4-dimethyl phenol. 3,4 dimethyl phenol. Dimethyl phenol. Heavy means methyl.
Four fluoro, three nitro.
Take a round off. Yes. Okay.
And four fluoro, three nitro, toluene.
So will it be 2 fluoro, 1 nitro?
Ankit, consider all of them to be the substituents.
So will it be like 2 fluoro, 1 nitro and 1 methyl benzene?
Okay, fine. But then you need to consider the lowest locant rule. Start numbering from that side where you end up getting the lowest numbers, or what you call lowest locant set.
We are considering everything to be prefix here.
So if you are considering everything to the prefix, alright, but what is the order? The numbering. Where are you starting the numbering from?
So with nitro.
With nitro. So if you are giving it 1 and 2, you are giving 2? This?
4 fluoro.
3,
Yeah.
4, 5 and 6. So I am considering this locate set first. That means 1, 2 and 1, 2 and 5. I get this one locate set. Alright. Considering the another one. One, 2, 3 and 4. I get 1, 3 and 4. So obviously this one is failed because this is preferable, right? Now Ankit, now we will see whether we will give name the nitrobenzene or toluene. That's fine कि ये toluene है, but you need to check for the lowest locate set because all of these are substituents. So if I start from here, 1, 2, 3 and 4. We have 1, 2 and 4. Can you please tell me which one is the real or the most appropriate locate set?
So 1, 2 and 4.
1, 2 and 4? Isn't it correct? 1, 2 and 4? Yes or no?
Yes, sir.
So start naming it from that. I mean according to that one. So what is the name? It is 1 fluoro.
1 fluoro, 2 nitro.
No, it's 4 methyl. M comes first.
Oh yes.
4 methyl. 2 nitrobenzene. I hope this is clear.
Yes, sir.
Is it clear?
Yes.
Everyone?
Yes, sir.
All right.
Yes.
Okay. Just a second. Next. This is this. Yeah. Chal.
Set 2, 3 dibromo, 1 phenyl,
Absolutely correct. Because when CH3 is a substituent phenyl, it is also a substituent. Sorry, good. Next, that one. Quickly.
4-nitroamylase.
4-nitroamylase. The nitro is a substituent. And NH2 is a functional group. Difference.
Yes.
4-nitroamylase. The last for today. और ऐसे ही हम 6 to 7 डेली क्लासेस में nomenclature. Valencies खुद से complete करना. Complete the valencies. Tell me the name.
The 3-5-di.
Yes, 3-ethyl 4,4-dimethyl heptane.
3-ethyl
and 5-di.
4,4-dimethyl. See. Do not get confused with D. This D is for the number, but you will consider alphabetical order with M only. Okay? This M and this E. We know that E comes first. That's why ethyl coming first. 4,4-dimethyl heptane. I hope this is clear.
So you are the three.
1, 2, 3. 1, 2, 3, 4. So definitely I am going to start from this side. So 1, 2, 3 पर there is ethyl, 4 पर there is methyl and ethyl. Now I have two substituents, so I will name them according to the alphabetical order. Is it clear?
Yes.
Kavya, am I audible? Kavya, are you there? Manjesh? Manjesh, can you hear me? Tell me. Please write in the chat box if your mic is not working.
So कल आपने hyperconjugation के बारे में बताया.
Correct. Alright, clear. Alright. And Manjesh, please confirm if you are present.
Yes, sir.
Okay. Can you hear me? Yes, am I audible? Alright. So, in the last class, we were discussing inductive effect, right? Inductive. So, like I said, if we have a carbon chain and for example, I substitute it with a group Z. Okay. That Z can be an atom or a group of atoms. If it is an atom, I will consider electronegativity. If it is a group of atoms, I will consider group electronegativity. So suppose, if this Z is what we call withdrawing the electron density from the carbon, here I will have a partial negative, here I will have a partial positive, here I will have partial positive, and so on and so forth. And we also discussed that partial positive is greater amount than this, because the most efficiency will be at the first carbon. So such type of groups, they are called negative I groups, and like it's clearly visible, they are electron withdrawing groups. From now onwards, I will use this word, electron withdrawing group. And if reverse is a thing, in this case, if it is releasing the electron density, then I will have partial negative here. So, in this case, this group will have partial positive, and such group is plus I. Electron donating group. Okay, so from now onwards, I will be using electron withdrawing and electron donating. So I gave you the series also, plus I and minus I. So let me, if you have any problem, I can simplify it. Simplify it to whatever is required at your level. So let us write for minus I first. Minus I means that they want electrons. They want electrons, and we know that if some species is having a positive charge, that is the most input for the bond of electron. Okay, that is most in the bond of electron. So, like for example, if I have NF3 positive, okay, that's first, followed by SR2 positive, followed by NR2 positive, followed by then we have, this is important, then we have nitro, then we have SO3H, yes or no?
Yes, sir.
Then we have cyanide. Now, why I am writing this series again, because today when we will be doing the application part of inductive effect, we will be discussing the acidic strength and stability order of the carbocations. So there, if I am like substituting it with this group and this group, so you need to know which one is having more minus I effect. Okay? Then only you will be able to answer the questions. Uske baad we have the aldehyde group, then we have the acidic group, then we have the halogens, chlorine, bromine, and iodine. ठीक है, इसके बाद आप कर सकते हो OR, OH, then benzene, then alkene, as in that. ठीक है, so this is what you need to remember. And please remember, there was a question. So there it was CN3, NO2, and Cn. So you should know that carbon with 3 fluorine is very highly electronegative. Is having very high electronegativity. So the order will be very.
Sir, why benzene shows minus sign effect?
इसका देखो मत, क्योंकि बेंजीन के पास भी इलेक्ट्रोनेगेटिविटी है. What we say. Ankit, it shows, जब आप अभी, as of now, do not consider this. This will be helpful in resonance. I will be dealing with resonance just after this. So वहाँ पे भी I will take. Okay. So this is the order.
Okay, sir.
Next, plus I. So plus I means that they already have the electron density on themselves. So they are disposing their electron density, the dispersal of negative charge. So obviously the ones which are carrying the negative charge, they will be the ones with maximum electron density.
Yes, sir.
In comparison with respect to the neutral ones. So let us start with that. I told you that CH2 negative, and we have NH negative, O negative, and this. So I told you this is the order.
Yes, sir.
Yes, why? Because oxygen is having the maximum tendency to hold the negative charge. So if it is holding the negative charge, it is not giving of its electrons. So that is, it is having a weaker plus sign. Okay. And then do you know this? If I have a 3 degree, this is 3 degree, I can write it in this manner. This is a 3 degree, then comes your 2 degree, and then comes your 1 degree, and finally CS. Okay, is it clear? And
yes, sir.
And one different series among isotopes. Please do not forget this. Among isotopes, the one with more atomic mass. Yes, the one with more atomic mass will have more of vibrations. Because of that, it will be. Sorry, the one with more of atomic mass will have least vibrations, better donation. So T, D, and H में this is it. और इसका पैसे लिख सकते हैं CD3 then CD3 yeah और CH3 को तो हम reference we consider reference for this we consider for hydrogen when hydrogen is attached to carbon I consider this to be that electronegativity difference is 0 and inductive effect is also 0 so that's my reference yeah Chalo, very quickly one of the most important applications of inductive effect acidic and basic strength. Now since we have only studied inductive, so I will be giving only those examples where I will be applying only inductive effect. Once we are done with hyperconjugation and resonance, then I will be giving you cumulative questions where you will be seeing whether it's resonance, over inductive or whatsoever it is. So acidic and basic strength. So for this, you need to understand or you need to know the order, the series plus D and P rule. D and P rule. I'll tell you what. D stands for distance, N stands for number, and P stands for power. Power means series. लेकिन उससे पहले you need to see distance. I'll tell you what it is. I'll tell you what it is. Clear? First of all, if I have an acid, look here, right? Later, if I have an acid, what is an acid? Acid is the one which is giving off its H plus. So, and I'm talking about what we say bronzed acid base. Because I told you the organic way we generally talk about bronzed acid. So, इसमें if it gives off its H, I will have A minus.
Yes.
I'm calling this as acid, and this has its conjugate base. And we also know that a strong acid is having a weak conjugate base. ये भी है ना? Yes. A strong acid is having a weak conjugate base. For example, if I ask you please arrange the following species in the increasing order of acidity. चलिए बैठिए. कुछ नहीं करना. What you will do? form the respective conjugate bases. I will have F negative, O2 negative, sorry, S not O2 negative, I'm so sorry, OH negative. Wrong, I am talking about acid conjugate base pair. This is NH2 negative and this is CH3. These are the conjugate bases. Now, a weak conjugate base will have the strong acid, or इसको आप दो तरीके से देख सकते हैं. Check for the stability of base. If a base is stable, obviously it will be a weaker base. If something is stable, that's going to be a weaker base. I tell you why. You tell me one thing. Can I say that fluorine is most electronegative?
Yes. Sir.
So its electron holding tendency will be maximum, and hence this is most stable. And if it is most stable, it is a weaker base. Why? Because if it is holding its electron, why would it donate its electron? Okay. So check for stability of conjugate bases. If a particular conjugate base is stable, the acid corresponding to it will be the stronger. I hope you are getting my point. Yes?
Yes, sir.
Yes, sir.
So see, so is the stability, if I ask you what is the stability of these
Yes, sir.
stability order, so you will say F negative, OH negative. This is the stability order. And if this is the stability order, then this is the acidity order. This is the acidity order. I hope this is clear.
Sir, that means वो जितना
Yes, sir.
electronegative होगा उतना ज़्यादा ही वो weak base होगा.
Yes, क्योंकि the more electronegative means electron holding tendency is more, and if it is holding its electrons, why would it give off the electrons? This will give off the electrons better. So this is a better base. Sorry. And that this is a stronger base, strongest base among these. That is why CH4 is the weakest acid. Sorry. Next. So this was in a period. So period where we usually check for electronegativity, but in a group we check for
Group electronegativity.
no, we check for size. Sorry, you tell me now. Tell me very quickly. Arrange the following in the increasing order of acidity.
सर इसमें
So HI is maximum.
हाँ वो ज़्यादा stable
Sir, here we will do the reference to size.
Why? Why? First one.
electronegative है.
And least bond dissociation therapy.
Ankit, why are you? The problem is that you amalgamate every XYZ things whatever you started in answering one question. When I am teaching you something, why don't you answer me using this concept and bringing into something? Okay, fine. See, I can answer this question from so many concepts, but you are starting something as of now. So try to answer it using that concept. Yes, Shri, Reshma, Ankit, Ikra, Gayatri, Manal, tell me.
Yes, sir.
Yes, sir. Yes, sir.
Tell me.
Sir, because of its high electronegativity, I will take the
No, I think least electronegativity है. देखो, अब यहाँ पे फैक्टर आएगा साइज. Iodine being of maximum size, can I say that negative charge is better dispersed in I negative? The electrons are better dispersal of electrons. So electrons are better dispersed in a larger iodine. Whereas in a period, size doesn't matter much. So there we check for electronegativity. So better dispersal of negative charge, and here least dispersal or poorest dispersal of negative charge because of the small size. So if that is the case, can I say this is most stable?
Yes.
Please, this is not the order of acidity. Again, I am telling you. This is स्टेबिलिटी। एंड आप भूल जाओ, अब आपको बेसिसिटी को भूल जाना है। जब मैंने बोला भूल जाना है, इसका मतलब यू हैव टू अडहियर टू इट, ठीक है? मत सोचना, क्योंकि अभी मैं आपको मॉलिक्यूल्स दूंगा तो आपको मॉलिक्यूल्स देखकर बहुत अजीब लगेगा कि ये कैसे बना होगा, उसमें जानना ही नहीं है। यू डोंट हैव टू गो इनटू द निटी-ग्रिटीज ऑफ हाउ आई हैव गिवन दैट पर्टिकुलर मॉलिक्यूल। मुझे उससे मतलब ही नहीं है, मुझे सिर्फ एसिडिक ऑर्डर से मतलब है। और मैंने सिर्फ एक चीज ही सीखी है, in order to find the acidic strength, simply make the conjugate base and check for stability. As simple as। इसके अलावा मुझे कोई आंसर नहीं चाहिए। बॉन्ड डिसोसिएशन एनर्जी, रेजोनेंस एनर्जी, दिस एनर्जी, दैट एनर्जी, ठीक है? चलिए, poor dispersal of negative charge. So if this is the stability, that's the acidic strength, ठीक है? चलिए, तो ये तो हो गया आपका नॉर्मल। लेकिन coming to inductive effect, what's the application of inductive effect in finding out the this? Yes, tell me. This one. This one. देखो, Manjesh, when I was talking about these acids, you know that these are the elements in a period, the second period. So see, if I ask you which acid is the most, which acid is most acidic, but which one is most acidic? So what you do, you just simply make the respective conjugate bases and then check for stability. The one which is most stable will have the most acidic, ठीक है? Will have the most acidic strength of the corresponding acid. So F negative is most stable. Why? Because F is having the maximum tendency to hold its negative electron, ठीक है? So if it is having the maximum tendency to hold, that means it is stable. That negative charge on F is stable. The point is that negative charge on F is stable. Like I usually say that positive charge on oxygen is not stable because it's electronegative. Why would it want positive charge on itself? ठीक है? So since this is most stable, the acid corresponding to it will be most acidic. As simple as that. But similarly, if I go in a group में क्या होता है? Size बहुत ज़्यादा increase हो जाता है. Why? Because there is an addition of an extra shell or extra principal quantum number. So iodine is of large size, so better dispersal of charge. Better dispersal of charge. And if better dispersal of charge हो रहा है, that's more stable. ठीक है? क्योंकि यहाँ पे हमें electronegativity concept we won't be applying. All right.
तो बेसिकली हम ग्रुप्स में साइज देखते हैं और पीरियड्स में इलेक्ट्रोनेगेटिविटी.
यस, क्योंकि पीरियड में देखो कार्बन इज 2.1, हां, एंड फ्लोरीन इज 4, जबकि यहां पे कितना था? 0.5, 0.3, 0.2 ऐसे डिफरेंस आता है, ठीक है? 4, 3.5, दैट सो ऑन, ठीक है? तो इलेक्ट्रोनेगेटिविटी डिफरेंस इज नॉट दैट सिग्निफिकेंट. व्हाट इज मोर सिग्निफिकेंट इज दिस साइज. नाउ so I said, so you need to remember, acha, first of all, so एक बात बताओ, if I have this, ठीक, so if it gives off its edge, can I say it will have a positive charge?
Yes, sir.
Yeah, there is a formation of carbocation. Yes or no?
Yes, sir.
But आप इसको ऐसे मत करो, इसको ऐसे करो. Other if I am having this CH3, CH2, CH2, because we will be talking about talking for alcohol and carboxylic acids. So this is an alcohol. I know that this is your active edge or acidic edge. Why? Because it is connected, it is attached to the electronegative oxygen.
Yes.
So it is acidic edge. Now what I am doing, so there is a formation of this. कार्बोकेटाइन की स्टेबिलिटी इसके बाद क्या है? CH3, CH2, CH2 and O negative. You tell me one thing. This is obviously unstable as of now. But if I attach something which increases or helps in the dispersal of this negative charge, then this particular species will be stable. बस मुझे stability देंगे. So what I am doing, fluorine here, what happens? Fluorine is electronegative. It will pull the electron density. So electron density pull हो रही है, इसका मतलब dispersal of negative charge is there, not accumulation. And if I do like this, the simple one में this whole thing is acting as a plus I. Yes. This whole thing is acting as a plus I. Here it is acting as a minus I. Here it is providing electron density. तो यहाँ पे dispersal of charge हो रहा था. Here accumulation of charge. Here there is dispersal of charge, leading to stability. Leading to stability. And here accumulation of charge. Already charge है और ज़्यादा charge दे रहे हो. ठीक है, charge कम करना होता है सबको stable होने के लिए. आप और ज़्यादा charge उसको provide कर रहे हो. So accumulation of charge leading to
stability. Unstable.
Yes, ठीक है. चलो. So can I say that acidic character or acidic nature is directly proportional to electron withdrawing groups?
Yes, sir.
The presence of electron withdrawing groups? Yes or no?
Yes, sir.
And inversely proportional to the presence of electron donating groups? Tell me yes or no?
Yes, sir.
Yes, sir.
एक तो ये फैक्टर है. अच्छा एक चीज और, let me tell you just one more thing. एक चीज बस. यहाँ पे मैं बता देता हूँ. नहीं. Here, देखो. CS3F CS3CH2F CS3CH2CH2F. देखो, as the carbon chain is increasing in length, it will have more of plus I. ठीक है? So plus I, if I arrange it in the order of plus I, then this is the order.
हाँ तो अपनी unstability उसकी.
ठीक है? जितनी ज़्यादा लंबी carbon chain हो जाएगी, that will have more of plus I. I hope this is clear. Ankit, Shanuka, Pujitra.
Yes, sir.
Yes, sir.
Because here this group is plus, showing plus. Here this and this. ठीक है? So as the carbon chain is increasing in length, that is going to have more of plus I. Next. So better dispersal of charge density, and here and in case of plus I, there is an accumulation of electron density, and accumulation of electron density making it less stable. Sorry, unstable. Acidic character is either proportional to the presence of electron withdrawing and inversely proportional to the presence of electron donating or electron releasing. Now, and this is one thing, and the other thing is DNP. Now I'll tell you what DNP is. So very simple. The first one is very simple. Just a second. Let us start with the first one. Arrange the following in the order of acidic strength quickly. Consider everything ABC.
सर फिर CBA.
हाँ बताओ.
CBA.
CBA.
BCA.
BCA. Increasing order में बता रहे हो?
Yes, sir.
Which one is having the least acidity?
B.
देखिए. So submit there is a removal of this negative, there is a removal of this negative. अब इतना भी नहीं करके देखना आपको, but since this is the first example, so negative charge का stabilization we need to check. So it is stabilized the most in case of NO2 because NO2 is exhibiting the most minus I among NO2, Cl and Cl. So the one which is exhibiting more of minus I, it will be showing, or it will be disposing, it will help the most in the disposal of the electron charge density from both negative. So A is the most acidic one. Okay. Now in this case, DNP obviously not working because the substitution is at the first carbon only. Now the next question. In the next question, first of all, let me write the question. सोच समझिए ABC जल्दबाजी नहीं करनी है, सोच समझकर दिमाग लगा.
So
Yes.
जितना माइनस आया ज्यादा उतना एसिडिक पावर ज्यादा. Is it correct?
Yes. Yes, this is correct according to this line. Now, see, you don't have to worry about the answer if it is correct or wrong. Whatever knowledge you have gained till now, just answer me according to that.
BCA.
B.
हाँ सर BCA होगा.
BCA.
हाँ.
BCA.
This. BCA.
Yes sir. वही होगा.
Now comes the role of DNP. DNP is distance. First of all, check the distance. अच्छा पहले तो ग्रुप्स देख लो. अगर माइनस आई प्लस आई तो वैसे ही प्लस आई वाले तो काम हो जाएंगे. But since here we have three groups which are exhibiting minus I, तो वो possibility तो हम negate नहीं कर सकते. तो चलिए, F is electronegative, Cl absolutely fine. So now first coming distance. OH just adjacent carbon पर there is chlorine. Adjacent carbon chlorine, adjacent carbon NO2. Distance is satisfied. Moving on to number. Since we have more number of minus I, so C is going to be the most acidic. You will go distance, then number, and power will be at the last. So since we have two fluorine over here, so C is most acidic. And in दोनों में तो you just need to check the minus I. Since this is exhibiting more of minus I, so then A and then finally B. Now tell me, Shri, what you were saying.
This distance
Distance, देखो. Distance means the negative I group is attached to the carbon adjacent to oxygen. तो इसमें भी नहीं है. First carbon पर, here also first carbon, here also first carbon. So distance is
same.
Distance is same. Moving on to the next point, that is number. Now, I have two such groups on first carbon. I have one such group on first carbon. I have one such group on first carbon. So 2 means it is of more acidic strength. I hope this is clear.
So,
and then finally, the last point, power. Between these two, I need to check for the power. I know that NO2 exhibits more of minus I, so it is of more of. I mean, it will be more acidic than the second one. I hope this is clear.
Yes sir.
All right. Next one. Third, quickly. quickly. इसको थोड़ा और ठीक से कर लेते हैं, इसको ऐसे करते हैं, यहाँ पे इसको ऐसे तो और तो अभी भी ठीक है, बट उसके जैसा बनाने के लिए इसको ऐसे करते हैं, ठीक है? चलो, this one.
CBA.
Distance is same? No. अच्छा, C is least acidic, ना? अच्छा, C is least acidic, then it's B and then absolutely correct. Absolutely correct, because we know that negative I order में Cl is more than bromine. Absolutely correct. Next. Quick.
सर इसमें तो
BAC.
BAC होगा।
BAC. ठीक है? Acidic order.
सही है।
Yes. Clear? Yes. Yes. So it is BAC. All right. Next. Organic species. Simply write, you can write HAS.
सर फिर तो इसमें ABC
CAB. CAB.
CAB? Cab? Just a second, let me write CAB first. CAB देखो. Please check for distance first. First carbon.
अच्छा ठीक है
So obviously B is going to be the most acidic distance. Then the second one is the power. इसमें और उसमें इसकी power ज़्यादा रहती है. Is it clear? Yes, any problem?
Yes, sir. Clear.
Clear? Chale. Next. The last.
Yes, sir.
The last one. Just a second. ABC.
सर इसमें ACB होगा।
ACB होगा?
हाँ।
ACB होगा?
हाँ, ACB।
Yes, sir. ACB.
ACB is absolutely correct. So first you will check for distance.
Distance.
F there. इसमें तो ये तो last हो गया. Yes, so A is at the last. Then distance के बाद you will check number. Since here I have 2, so it will be most here. इसको मत देखना कि here in total I have 3. उससे मतलब नहीं है. Yes, I hope you get my point. Shireen, Ankit, Madar, Kavya, Manjay. I hope Manjesh. Yes, I hope you get my point.
Yes, sir.
Overall से मतलब नहीं है कि I have 3. ठीक है? I just need to go in a step. Alright. Now, so when you yes, tell me. Next is your basic strength. So basic, like for example, I have ammonia. Is that the lone pair of electrons?
Yes, sir.
And if it, like I'm having H plus, so it will donate its electron, and I say that I end up getting NH4 plus. Yes or no?
Yes, sir.
So that is the base, and that is, this is its conjugate acid. So suppose if I have this amine, can I say if I substitute this carbon with some group which increases the electron density on this end, that will be a better base? Yes or no?
Yes.
And I know that if I substitute a group Z, and if this Z is plus I, then it will increase. It will increase the electron density on N.
Yes, sir.
And if this group is minus I, it will decrease the electron density
Yes, sir.
on N.
Sir.
And if it is decreasing the electron density, that means the density available for donation will be less, and hence less base. So can I say that basic strength or basic character is directly proportional to the presence of electron donating group and inversely proportional to the presence of electron releasing groups. Yes or no?
Yes, sir.
So,
Yes? Any problem?
Sir, we go.
also,
Example, correct. Quickly. Basic strength.
so sir,
Yes, tell me.
if we are adding minus group, तभी तो वो इलेक्ट्रॉन डोनेट करने में डिफिकल्ट होगा ना?
Yes, that is what I meant. See, electron donating group तो increase, it is increasing the electron density on the end. तो जितनी ज़्यादा electron density होगी, तो more electron density will be available for donation, and hence it will be a better base. Yes or no? Chalo.
इसमें DNP रूल लगाना है.
इसमें भी लगाना है. Yes, DNP rule. इसमें as in इस क्वेश्चन में तो नहीं, but yes. तो देखो ये प्लस आई है, इसका तो मैं आई जीरो ही कंसीडर करता हूँ, और इसका माइनस आई है, तो A is most as basic, then B, and then C. As simple as that. Any problem?
No.
No problem. Second. Very quickly.
ABC.
मैं इसको गैस मीडियम में लेगा, क्योंकि एक्वस मीडियम में भी होता है ना मींस का बेसिक नेचर, बट अभी सिर्फ गैसेस मीडियम में बताइए. इज दिस करेक्ट? क्यों? वो 3 डिग्री है.
Yes.
और 3 डिग्री बेटर डोनेट करेगा, मोर इलेक्ट्रॉन डेंसिटी डोनेट करेगा टू मैग्नेट. यस. नाउ अंकित, यू वर सेइंग कि सर इसमें डीएनपी रूल लगेगा. नहीं, सॉरी, अभी बता दो. जस्ट अ सेकंड. चलिए सोच समझ के.
Sir, इसको तो
Which one is more basic?
one is more basic.
Second one is more basic. एक काम करो, इसको ना थोड़ा सा करो, एक्सप्रेस करो। अब बताओ और NH2 करो ना इसको। इसको NH2। अब ठीक है, अब बताओ।
First,
which one is more basic?
मुझे B लग रहा है।
देखो, first of all, this is minus 9 and this is minus 9, right? This is minus. So minus I तो वैसे भी हमारे लिए अच्छा नहीं है और basic strength, but फिर भी अगर थोड़ा दूर है तो it will be a better base than this, क्योंकि यहाँ पर इलेक्ट्रॉन पुलिंग टेंडेंसी ज्यादा होगी as compared to why, because inductive effect is distance dependent. तो नेगेटिव आई जितना दूर होगा उतना अच्छा बेस। आई होप दिस इज क्लियर। और प्लस आई जितना पास होगा उतना अच्छा बेस। इज इट क्लियर? एनी प्रॉब्लम?
नो
सर। अब एक क्वेश्चन है जैसे स्टेबिलिटी ऑफ कार्बोकेटाइन बताता है। स्टेबिलिटी ऑफ देखो कार्बोकेटाइन तो कार्बन चाहिए अपने चार्ज का डिस्पर्सल करना, मतलब अपने चार्ज को कम। सी कार्बन बॉन्ड्स इलेक्ट्रॉन्स, सो इलेक्ट्रॉन्स कौन प्रोवाइड करेगा? टेल मी, हु विल प्रोवाइड द इलेक्ट्रॉन? प्लस आई ग्रुप। So can I say stability of carbocation is directly proportional to the presence of electron donating and is inversely proportional to the electron withdrawing? As simple as that. ठीक है, कर लोगे? चलो एक दे देता हूँ, सिर्फ एक ही है, उसी से आप कर लो। CH3 CH3 CH2 and CH2 positive. Take out the time is this. Then I have CH3 CNO2 H CH2 plus and कुछ भी बना सकते हो। CH3 Cl H CH2 plus quickly ABC plus I
BCA
yes A तो सबसे ज्यादा स्टेबल होगा। Then NO2 का ज्यादा स्ट्रॉन्ग माइनस आई होता है as compared to Cn, तो then C and then VCA. Absolutely correct. I hope this is clear.
Yes, sir.
Okay. And जब very quickly stability of carbon ion उल्टा हो जाएगा। Yes. Stability of carbon ion. Can I say directly proportional to electron withdrawing group? Because again, dispersal of charge करना है। Dispersal means someone is pulling the electron, and inversely proportional to electron donating. Yes. Just one example.
maximum.
A can't be maximum. These are the positively charged species, and they are more. They exhibit more of minus I. So it is A, then B, then C. Simple. इसको भी अगर मैं इसको ऐसे कर देता हूँ NH2 NH2 plus NH3 plus NH2 plus NH3 हाँ ठीक था ठीक है yes simple
ये सर इलेक्ट्रोनेगेटिव ग्रुप की इनवर्सली प्रोपोर्शनल है ना?
Yes, the stability of carbon ion is inversely proportional to electron donating, directly proportional to electron withdrawing. Now in this question we have all the three to be the electron withdrawing. You just need to check the priority. कि किसे आप किसके ऊपर रखोगे? So obviously plus ONE2 will have more of than plus NH3. And finally F तो इनके बाद ही है. अंकित, इलेक्ट्रॉन डेंसिटी पॉजिटिवली चार्ज स्पीशीज को ज्यादा जरूरत है ना इन कंपैरिजन टू द न्यूट्रल वंस?
Yes sir.
So they will exhibit more of minus I. Simple.
Yes sir.
चलिए. So ठीक है. Right. Now since we can't start with resonance, but we can do hyperconjugation. That's smaller topic. See, hyperconjugation, other names भी होते हैं no bond resonance, Baker-Darton effect, so देखिए hyperconjugation. First of all, hyperconjugation means, अच्छा सबसे पहले ये देखना है. देखिए, for this, what you need to check, first of all, look for, no, ऐसे मत लिखो, इसको ऐसे लिखो, कि if you have a carbocation, अच्छा, उससे पहले, I told you what is the meaning of alpha, beta, gamma carbon.
Yes, sir.
Yes, तो देखो, if I have something like this, और मैं बोला था यहाँ पे अगर OH है. So I was calling this carbon to be alpha carbon, this to be beta, and this to be gamma. And अगर यहाँ पे H attached है, तो मैं बोलता हूँ these are my alpha H. Yes or no?
Yes sir.
The H attached to alpha carbon are alpha H. So ठीक है, ये carbocation है. The carbon adjacent to this carbon, which is bearing the positive charge, is your alpha carbon. This is your free radical. The carbon adjacent to this free radical is your alpha carbon. This is your alkene. The carbon adjacent to this alkene is your alpha carbon. First of all, आपको क्या करना है? Identify the alpha H. Identify the alpha H. देखिए, stability of a molecule, stability of carbocation, radical, alkene, ठीक है, is directly proportional to the number of alpha H. जितने ज़्यादा alpha H होंगे, उतनी ही ज़्यादा stability. Like if I give you 5 alkenes and if I ask you which one is most stable, you need to check for the alpha H. The alkene which is having more of alpha H is more stable. Now, and if I ask you how many conjugative structures, जो कि question आता है, how many hyperconjugative structures? Yes. So number of alpha bond in breaking ये आप ऐसे देखो, number of hyperconjugated structures by breaking CH bond. By breaking CH bond is also directly proportional to the number of alpha H. जितने alpha H उतने ही hyperconjugated structures. एक एग्जांपल लेते हैं. For example, CH3 CH2 plus. This is a carbocation, right? ठीक है?
Yes.
Now, how many alpha? First of all, this is alpha H. No. So, for hyperconjugation to take place, there should be the alpha H. First of all, conditions देख लो. There should be alpha carbon with alpha H. With alpha H. ऐसा alpha carbon हो सकता है, पर जरूरी नहीं alpha H हो उसके पास. तो but hyperconjugation के लिए यूनिक, तो इसको सिंपल लिख लेते हैं. alpha carbon की जगह सीधे ही alpha H. Should have alpha H. And alpha carbon should be sp3 hybridized. ठीक है? ये दोनों. तो ये alpha H है, alpha carbon, and it is having how many alpha H? 3 alpha. That means मेरे पास 3 hyperconjugated structures होंगे. कैसे? Breaking CH bond. So let me shift this bond here. So I will have और H plus ऐसे लिख लो. तो क्योंकि यहाँ लाइन है, इसीलिए इसको no bond resonance की बॉन्ड. ये हो गया?
Yes sir.
Yes. अदर स्ट्रक्चर होगा, अगर मैं ये वाला रिमूव कर देता हूँ, yes? Yes or no?
Yes sir.
और एक और hyperconjugated स्ट्रक्चर अगर ये वाला हो जाता है, this one. Yes or no?
Yes sir.
So how many hyperconjugated structures?
3.
3. Why? Because I had 3 alpha. Is it clear? Yes, is it clear?
So,
very quickly, tell me how many hyperconjugated structures are possible. How many hyperconjugated structures?
8.
8? देखो, adjacent to this, alpha, alpha, alpha. I am having 3 alpha hydrogens. 3 alpha hydrogens and 2 alpha hydrogens. So 6 and 7, absolutely correct. 8. 8 is the answer. Bilkul. Is it clear?
Yes sir.
Is it clear?
Yes.
Very quickly. इन दोनों
1.
इसमें 1 इसके लिए अल्फा ये और यहाँ पे एक ही हाइड्रोजन है, so 1 का अल्फा है. इसमें
7.
1 2 3 4 5 6 and 7. ठीक है? This is H, this H, this H. Yes or no?
Yes sir.
तो कितने हुए?
7.
7 alpha H. Clear?
Yes.
नहीं? देखो इसके एडजेसेंट ये भी अल्फा और ये भी अल्फा इसके एडजेसेंट और उनके पास कितने और तीनों की sp3 हाइब्रिडाइज्ड. अगर ये मैं ऐसे ले लेता ना यहाँ डबल बॉन्ड, तो ये वाला ये क्यों नहीं करते थे क्योंकि वो sp2 हाइब्रिडाइज्ड। I hope this is clear.
Yes.
Yes, is it clear? All right. चलो रेडिकल्स का देखते देखो, CH2 फ्री रेडिकल अगर ऐसा है, so CH3 radical में homolytic cleavage होता है, so this bond will break like this, ठीक है? I have a radical here, I have a radical here. This radical and this radical will form a bond. कोई प्रॉब्लम? ऐसे ही दो और स्ट्रक्चर हो जाएंगे, और बना, तो कितने H थे? 3 alpha H, इसलिए कितने 3 hyperconjugated structures. 3 hyperconjugated structures. Is it clear? Tell me. Now,
yes sir.
CH3 CH2 plus हो या CH3, चल ठीक। एक बात बताओ, CH CH2 इसको ऐसे दिखा सकता हूँ। देखो कार्बो के टाइम होता है वो प्लेनर होता है,
Yes.
इसके पास एक ऑर्बिटल, जिसके पास मैं बोलता हूँ वैकेंट ऑर्बिटल, वैकेंट p ऑर्बिटल, वैकेंट p ऑर्बिटल। और ये वाले जो बॉन्ड्स हैं ये किससे मिलके बने होंगे आपको पता है, ये sp3 हाइब्रिडाइज्ड कार्बन प्लस s ऑफ हाइड्रोजन से मिलके बना है। यस और नो?
Yes.
यस। तो देखो जो ये वाला बॉन्ड होगा, ये वाला, इसको मैं ऐसे दिखा सकता हूँ, दिखा सकता हूँ।
Yes.
ये H होगा और ये sp3 हाइब्रिडाइज्ड, तो बेसिकली यहाँ से इलेक्ट्रॉन का डोनेशन वहां होगा, याद रखना है। तो और यही केस चाहे ये कार्बोकेटाइन हो और रेडिकल हो, रेडिकल में भी तो अच्छा रेडिकल में थोड़ा डिफरेंट है। तो कार्बोकेटाइन में अगर पूछे कि कहां से कहां इलेक्ट्रॉन का मूवमेंट हुआ है, तो sp3 हाइब्रिड ऑर्बिटल से वेकेंट
p
p ऑर्बिटल, ऐसे निकाला जाता है। और रेडिकल्स के केस में देखो, रेडिकल के केस में भी I have a p orbital but it is having one electron, it is short of one electron and I say it is half filled. So can I say here it will be sp3 hybrid orbital to half filled p orbital, half filled p orbital. Any problem?
No sir.
Any problem? Yes, any problem? ठीक है। और तो sp3 हाइब्रिड ऑर्बिटल्स, sp3 हाइब्रिड ऑर्बिटल। अच्छा, इसको हम ऐसे तो लिख सकते हैं कि sp3, देखो हमें पता है कि ये जो कार्बन और हाइड्रोजन का बॉन्ड है, जो कि ऐसे बना हुआ है, राइट? इसको क्या बोलते हैं? सिग्मा।
सिग्मा।
तो इसको ऐसे तो बोल सकते हो कि कार्बोकेटाइन के केस में सिग्मा टू p वेकेंट p, और रेडिकल के केस में सिग्मा टू
हाफ
लिख सकता हूं?
Yes sir.
सिंपल, ठीक है। Alright, then thank you so very much. Do take good care of yourselves. We'll meet in the next class. We'll continue from here. We will try to wrap up this